Hey there, math fans. Dr. Andy Lovelace. This is a problem from our precalculus course, this picture that you're seeing on the screen. Below it, I have an animation that I just created for it with a hot air balloon, and there I have Harry the Husky and Butch, the mascot for the Cougars, ready to help us. As we watch this hot air balloon, I'm going to keep note of how high it is above the plateau, which is the x-axis, and above the sloping ground. And there's an interesting phenomenon, so we're just going to kind of let that go. I have a few students on the discussion board that are really frustrated by this problem, and I understand why, because they found the x and y coordinate of the vertex, and that worked, and they were happy, and things were sort of going all right. And then the question said, what is the biggest vertical gap? So between the ground and the parabola. So there's a couple examples of vertical gaps. And they made what seems like a reasonable assumption. They just said, well, I know where the vertex is, so let's just find this. That's it. The problem is that logic is not right. It is not true just because you have the vertex of one parabola that means that gap is different, is the biggest gap. And we're going to see that. If you're looking at the numbers, you'll notice this. But let's kind of just do a little thought experiment. So let's say you have a parabola like this. And let's say you know this is at, I'll just make up some number, 50. And let's say someone comes along with a line and just draws it however they want. Let's pretend they draw the line like this, just to be extreme. They draw the line really steep slope. Looks like this. And they draw the line here. So I'm going to exaggerate it a little bit. And then I want you to go to the vertex, and I want you to draw this vertical gap. Do you think that is the biggest vertical gap? I think not by a long shot. I think somewhere over here it's much larger. Can you see that? So just because you're at the vertex of the parabola doesn't mean the vertical gap between the parabola and some random other thing is biggest. This is something new. It's neither one of these formulas. So your job is to figure out what is the formula for the vertical gap and figure out when it's biggest. Now the way this picture looked, it was somewhat convincing that maybe should be it, but it's not. It's a little further over. You can see that in the animation that's been running. That even though let me click on it here, even when the balloon, stop balloon, was at the peak, which in my picture is about 100 feet, the number on the right, the gap between them, so watch what happens in the next few moments. I'm rounding it to the nearest foot, but it's 100 feet above the plateau, and then the other number is getting bigger. Wow, the distance from the plateau is getting smaller. That bothers people. Understandably, because you sort of think, can that happen? But I hope my picture or my more extreme version, and if that's not extreme enough, sometimes I like to joke and make the next picture. What if I drew a line like this? And I said, when is this gap biggest? It's definitely not going to be at 50. So there's a certain point where this becomes pretty convincing. What if I drew the line through the point? Then the biggest gap is not going to be at the vertex. Okay, so your job is to figure out a formula for the vertical gap. And that formula has not been given yet on the page. So we want the vertical gap that this is above this. And there's an easy formula for that. Actually, you did that in a previous homework. But it's a new thing you have to find that's not anywhere in the graph. And it's a fairly simple thing. I often have to do examples like this. I say, well, what if this is 50 and 70? And what if this is 50 and negative 20? Can you find the vertical gap? I find some students are weary about that, but most students tell me it's 90. And I say, how did you do that? Well, I did the y value for one, and I subtracted the y value for the other. I'm like, does the negative matter? No, not really. Oh, so the vertical gap is the top y value minus the bottom y value. And they're like, yep, okay, sort of get that. So what do you want? You want the top y value minus the bottom y value. That will give you a brand new formula that represents the vertical gap. That brand new formula happens to be a quadratic. What bothers people is we haven't graphed that quadratic, and that's true. If you were to graph it, it's a different quadratic. But the question didn't say graph it. The question said, when is it biggest? So once you have that new quadratic, you'll be able to do so. So this entire problem is just using this. And you use it first on this to find where that highest value is, the highest value above the plateau. And then you're going to use it again on this new function you find. And in the new function, one of those numbers will have changed, either B or A. Okay, I wanted to say all that because there was a lot of frustration on the discussion board, but also it's just kind of fun. It shows you the bigger thing happening here is an understanding of the function represents that orange length that is different from this red length. That red length is a different function altogether. All right, I hope that sort of helps. Let me know if any of this is interesting to you. All right.